Hey everyone, and welcome to another episode of the LEGO Train Container Terminal. Last episode we ended with low pressure problems in the pneumatic system. But before we get to that, there was a question on the previous video, and that was about if I had already thought about a layout for the container terminal and how big it's going to be and stuff like that. Well, actually I don't know yet. In the first episode I showed you that there's going to be two cranes that will load and unload the trains and put the containers on a monorail system that goes to a third crane, which then I don't know, stores it, stacks it, something like that. I don't know yet. So that's a general thing. And how big the layout is going to be, I'm going to do it in my attic. So it's going to be like 3 meters wide is here or something like that, and 4.5 meters deep, I don't know, long, something like that. So that's the rough size that I'm able to use, let's put it like that. Maybe I'm thinking about adding a harbor or something like that to have additional something, but that's still far away. Next to that, the two cranes that I was talking about, two of the same principle that we're building now. So there's going to be a copy of the crane that we're building now. Well, I'm not sure about that. So there are two reasons for that. The first reason is that the revenue on my main channel is plummeting. It's like with the same amount of views as last year, it's like 50% down. And it has to do that a lot of views are now coming from low CPM countries like India and Indonesia. You guys are welcome, of course, but I'd rather have more views from Western countries, since the revenue can be like, there's a difference of like 5 to 10 times on the ad revenue between a Western country and countries like India. So that's a bit of a big deal right now, so I need to cut costs. That's one reason, and the second reason for cancelling the second crane is actually the amount of problems that I run into. So we get this one fixed, I'm sure about that, but I don't know, it's not gonna be as reliable as I was hoping for. So unless I see that it's very reliable and the revenue is going up again, then I can always consider to make a second crane like this one. In the end there will be two cranes, of course. This one will be there and the other one at the end of the monorail system, which can stack containers, will be there as well. So well, yeah, that's something, it's not decided yet, but you should take into account that there's a big possibility that the second crane of the crane that we're building now is going to get cancelled. Alright, now back to the previous episode. There was a problem with the pneumatic system that didn't go higher than 39 or 40 psi. And 40 is the bare minimum. But when you're using air, the air pressure drops. So in sequence of picking up a container, you move the arm down, it uses air. You close the grabber, it uses air, and then you lift it. But by the time you lift it, you already used so much air that the pressure has already dropped to 35 psi if the maximum is 40. So, and 35 psi is just too low to lift a container up. So that was a problem, but I found the problem. And actually I need to say problems, since there were two problems that causes the low pressure. In engineering we call that double jeopardy, and that's something normally that you can discard, because in the real world in engineering you use systems with a reliability of around 99% or even higher. And the probability that two systems at the same time will fail is just, it's so low that you can discard that. But unfortunately we're not living in the industrial world, but we're living in Lego land. So that means that Lego laws do apply here, and that gives a lower probability of the systems. So the first problem was actually that a hose was a bit ruptured, and that probably occurred when it was very hot here in the attic. It was around 30-35 degrees, I believe, something like that, and the sun was continually burning. And it was also a very hot period here in the Netherlands and the rest of Europe. So what I was actually doing was, I got sweaty hands, so when I needed to put a hose on the cylinder, I was using my nail to actually put it on, to, you know, to squeeze it on. And I think I cut a little hole in the hose with my nail, and that caused that problem. That was the first problem that I found, but then the issue wasn't solved, and it turned out that this little here, I shouldn't say that, this little thing here was the problem, and it has a broken steel inside, so it goes to 39-40 psi, and that's it. Then it starts leaking. And my theory is that I applied too much force on it. So the compressor was always running to 50 psi. It waited until the pressure was dropped again until 40, and then it started again. So I think that's the reason why this one started leaking. So as a safety precaution, I started using the compressor at a maximum pressure of 45 psi instead of 50. And I hope to avoid these kind of problems in the future. But it gives another problem, and that is we do not have enough pressure to lift the containers. And that is why I was looking for a better solution. And I tried a 4-cylinder configuration, and that didn't work out like I wanted it to be. But after that I tried a different approach, and that actually did succeed. So let's have a look at that. So to be able to fit in 4 cylinders, I rebuilt the whole yellow part of the crane. And as you can see on the top now, there are 4 cylinders pulling the arm up and down. But of course there is a problem occurring with this configuration, and you can see it when I hold the camera perpendicular to the crane. You can see that the grabber, the black thing, isn't straight anymore, but it's twisted a bit to the right. And that is because when you look at the lower side of the yellow part, yeah, I've only one hand to hold the camera with. You can see here the axis that moves around, this one, and there's one as well. And these axes are now 12 studs long, and there's a bit of mechanical play going on around here, and that has to do with the fact that the cylinders are just too powerful, and they're just ripping the whole crane apart. And I don't know if you can see it, but let me just point the camera a bit like this, and I don't know if it's visible. It's visible in the with my eyes, but not on the small screen of the camera. But as you can see, as I hope you can see, the scissor lift system is just a bit ripped apart on the first segment. That's what's happening when the crane is actually pulling up the arm. There's no way I can prevent this, because, you know, I can straighten it out again, make it straight again. It goes nicely down straight. When it comes up again, it's not straight anymore. So that's why I need to abandon the 4-cylinder configuration. It's just too strong. I also played a bit with the pressure reducer that I've installed in here, but that didn't work either, so they just remain too strong. It's a combination of 2 cylinders which have quite a bit of force, and the length of the axle that is too long now, the 12 studs length. So I'm going back to the 2-cylinder configuration, which isn't a big deal actually, since I managed to solve the leakage problem, so I can operate the crane at 40 psi again. So I'm back to 2 cylinders, but I can't get it working properly. And I've made a radical decision. I'm already struggling for like 3 months or so to get this setup working, and I can't get it to work like this. So I decided to eliminate the biggest variable of this system, and that is this construction here of the grabber. You know, it's wobbly and it causes a lot of headaches and stuff like that. So what I'm gonna do is I'm gonna replace that with well, I built a prototype, and that's what you see here. It's not finished yet. It needs to be more stable than it is now. Wait a second. I can actually use guiding rails here as well. So I've installed the guiding system that you see here, which are 4 Technic axles that move along with the arm. But of course there's another problem. And that is when I want to move the arm upwards, it doesn't come any further than this. And as you can see, it's not high enough. There needs to be a container under here as well. It needs to go up any further like that. But it doesn't do that, and it's because the extra Technic axles on these sides provide a bit of extra friction. And I just turned into a 2-cylinder system again, and I thought that would be enough, but apparently that is not enough. So now I need to change the whole thing again. And since I built in the, let me just switch off the power. And since I've built in the guiding axles within the reach of the cylinders, I cannot fit 2 more cylinders within this structure like it is now. So I need to come up with a solution for that as well. Alright, back to the drawing board. So what I've done here is making a construction for moving the arm, and as you can see, I've used 2 other pneumatic cylinders which are a bit longer than the other ones, so I can attach them on a different point on the scissor system, and by doing so it can use a bit of extra force, and that would resolve the problem of the extra friction caused by the guiding axles next to the grabber. So I finished the arm unit, and as you can see, it can extract and retract again. You see these little things here, here's one and here's one as well. Those are mechanical stops to make sure that the whole thing is centered, because when I remove it and it's extracted and you want to retract it again, it can actually occur that this happens. And now the whole system isn't centered anymore, but there's an offset to the left, because this one here should be like that. Now it's centered. So that's what the function of this little thing is, and it's pretty important, because when you have an offset like that, it will create an offset of the grabber as well, and that's something we do not want. So now it's a matter of putting it into the existing module, and if I did my job correctly, and I did, it fits nicely in the existing module, since I kept the form factor the same. Then we're gonna attach the grabber, hook up the pneumatics, and we're gonna do a test. And I'm curious, since I didn't test it with a weight on below it. It's a bit difficult to really simulate it in a proof of concept situation, so I'll just put the system in and see how it performs in the real world. So I installed the new arm, and as you can see, it's too low now, and that's not a big of a deal. So the previous arm was actually built on the height of the container on the wagon, and since I changed the arm configuration a bit, also the length of the arm has changed, so it reaches a bit more down now, and I need to cancel that out, and that's not a problem because I already thought of that. And as you can see here on top of here, these are the axles, that one here and also one over here, that go all the way down. And if I adjust these bushes here, then I can regulate the maximum reach when it goes down. So let's set up the arm a bit. Put the wagon below. Let's say, well, this is a good height, I believe. And now have a look at the bushes and you see that there is a bit of space. And all I have to do is push the bushes a bit down and we're set. So I'm gonna do that, and then we're gonna see if it actually can lift a container or not. A problem occurred. When I put the pressure on, this happened. I don't know if you can see it, so I'll just light it a bit with the flashlight. As you can see, it fell off here. Because of the high pressure pushing down, it just came off. And that's a problem. I actually did already cheat a bit, and that's the following. These here had the same problem. So I already ordered Technic axles of 32 studs long. This is a 12 and a 16, so the new ones will be a bit longer. But the problem is that the same problem occurred with these ones as well. And I solved that by gluing them. Yes, I know, very, very bad. But let me explain. I don't want to wait another week for the arrival of the Technic axles. So I know I'm very purist about modifying Lego and stuff like that. This is something like this. Okay, I'll just cannibalize these parts for now, so I can continue. Otherwise, I have to wait another week. So I thought I was solving the problem by gluing these ones, but of course, what I didn't think about was that the same joint is over here, and that's busted now. So I can place them together like that, put them together, but once it goes down again, it'll crack open again. So I need to make something that fixes this, that keeps this in place by I don't know, a vertical lift arm or something like that. So once more, back to the drawing board, and we're gonna fix this problem. So I put a bit of reinforcement on the system. That's what you see there, those vertical black thin lift arms that weren't there before, and that keeps the whole thing together. So I installed the whole thing and I wanted to test it, and I noticed that it's not straight, and I don't know why. And I don't know if I can show you. If you peek through here, yeah, it focuses. Let me put it on manual. If you peek through here, and I keep it perpendicular to the crane, and if you look at the grabber on which I try to, it's on zooming. Alright, again, it's on the focused on the crane now, and look at the blue pins. I try to keep the camera perpendicular to the crane. That's the compressor, and you see there's an offset, and it means that the grabber is not straight, and you can actually see it as well. When you take a look at it like that, it's not very good visible, but when I place a container below it, you'll see that it's not straight. It's a bit twisted like that, and I need to solve that before we can continue. Because right now the problem is when I pick it up, it picks it up nicely from its location, no problem, but when I put it down again, well, let's try. I think it'll work. Let's grab it. Let's pull it up. Oh, you see, it works. It has force enough now. You see that the container isn't straight now. You can see it from this angle very well. It's not hanging perpendicular to the wagon. So when I put the container back on the wagon, you'll see that it's not centralized anymore. Well, actually it is. So the problem is less big than I expected. But still I want to check it out. I want to see if I can fix it. Because it's another variable that can cause troubles later on, as we all know. So I haven't solved the problem yet, but I've noticed that when I take off the pressure, or let's say take off the cylinders from the scissor mechanism, the thing is straight again. So it has to do with one cylinder probably extending 1 millimeter further than the other one. I tried to measure it, but I wasn't able to measure it very correctly. So what I'm now going to do is, when you have a look at this, let me just yeah, this is where the cylinder is connected, and this is the maximum extension of a cylinder. So there's like half a stud extra. So what I'm gonna do is gonna make these cylinders extend all the way. So I'm gonna make sure that their extension is the same. At least that's what I hope. And I'm gonna do that by, well, I don't know if you can see it. The scissor system is hanging on these lift arms here and there, and on the other side as well. And these lift arms are 4 long now. I'm gonna make them 5 long. So they're gonna be more distance between the actual scissor system and the cylinders. It's gonna be messy because that's the downside of studless, that it's all connected together. So I need to take apart the whole crane again. And well, I hope that'll solve the problem, because I'm not sure, but it's a guess. I don't know else what to do. Alright, that did the trick actually. And so it's straight now, and we can continue. Let me show you. You've seen it, but let me show you again. We're going down, grabbing the thing and pulling it up. Oh, you see that? Let me just... Did you see what happened? The grabber wasn't strong enough, and that was because I lowered the set point of the compressor a bit. Before it was like, it was enabled at 40 psi and then disabled at 50 psi, and when it dropped until 40 it was enabled again. I changed that to 40 and 45 because 50 was a bit high, and it was I believe beyond the maximum capacity of the pneumatic components, and it was putting a lot of stress on them. So I lowered the set point now, but by doing so, using some air, to go down, grab them and then come up, the pressure in the system drops again from 45 to 40. You did hear the compressor kick in, and that is that's a problem, because right now, if we want to move containers, we're gonna have a lot of pneumatic actions in sequences, and the compressor cannot deliver the power it should deliver. And I already anticipated on that, so I got the parts and we're gonna make a bigger compressor. So we solved a few problems again, and we're getting close to a working system, I believe. So we solved a few problems again, and we're a step closer to a working system. Next episode we're gonna upgrade the compressor. I already got all the parts needed, because I was already anticipating the problem, and also because there's a second train that needs pneumatic pressure as well. So we're gonna upgrade the compressor, and then we're gonna see if we can make some containers move. So hope to see you then. If you have any questions, let me know. Ask them by replying to this video. Subscribe if you haven't done so, and like this video if you really like it. And I hope to see you next time. Bye!